Okay, so this is going to be a quick introduction to how power laws interact with polynomials. Okay, who can tell me what the first power law is? What's one of the power laws? Yep.
The product of powers.
Product. And what does that mean? What do I do when I have the product?
So the product is multiplying, so you add them.
That's right. So if I'm multiplying the same base exponents times 4 to the 3, this is going to be 4 to the 2 plus 3. Right? So when we're multiplying our bases, we're adding. What's the quotient law? Yep.
Oh, the quotient law? I was going to say the one with the zeros, but
we can talk about that one. You want to do the
I was going to say
this
one where it's
this one?
if there's a zero, it's only one.
It's always one.
It's called the zero law.
Yeah, the zero law. Fantastic. Okay, what's my quotient law? Yep.
Quotient law is where if you have a division.
On the same basis?
Yeah, same basis. If you have a division, you just subtract the two
Exponents.
whatever they're called.
Yeah, fantastic. Yeah.
I don't know.
The power to power law is when you have a bracket with a number that that has the exponent, and then on the outside there's another exponent.
Awesome. And how do I simplify that?
You're multiplying.
I multiply. So this is going to be 4 to the 2 times 4. Yeah, that's the quick review. Yeah.
When you have different bases, it's boring old bed maths.
Boring old bed math. I like that. I have to quote that one. That's fantastic. Yeah.
And then there's the one power law, which is it's just equals the same answer no matter what.
What a ridiculous law. Why do we even use that? What about this? What if I have 4 cubed plus 4 to the 3? That's the same thing.
Then you have to solve it.
I have to solve it. I have to go 4 3 times. There's no laws for that. Okay, so the one big law that you need to remember for this to make sense, and this is why polynomials, it took me 4 years to be able to teach this in a way that hopefully makes sense. Otherwise, we're just kind of throwing stuff around and distributing. It has to do with this, the cumulative law. Does anyone feel confident in explaining the cumulative law? Yep.
The cumulative law is like, so like if you have two big numbers with two little numbers, exponents at the top.
You sure?
Yeah. No. You have a base and another base.
Okay, you don't even need a base for this one. Okay, this doesn't have to do with powers.
3.
Good guess though. Yeah, Liv. The person in the front.
It's like how multiply is like adding, the sign looks like the same.
Yeah, awesome. So with this, does it matter what order I do that in? Can I rewrite this 3 times 3 times 6 times 4? Does it matter? If I'm just multiplying, does it matter what the order is?
No.
That is called the cumulative law. Same thing with adding. If this was all adding, does it matter what order I add them up in?
No.
No, it doesn't. Knowing that, I half expect you to like throw it up and be like, that would be awesome. Yeah, totally. All right, so we know that we can rearrange these, okay? There's only 2 hard things in this whole unit. The first one is understanding why we can use power laws within here. Do these have the same basis?
No.
They don't. So technically the power laws don't apply. However, what operation is between the 4, the 2 A's, and the B?
Multiplication.
Well, so can I actually write this 4 times 2 squared times B times 3 times A cubed times B to the 4th times C? Can I do that mathematically?
Yeah.
Do you see that? Now let's apply the cumulative law. Cumulative law states what?
You can rearrange
I can rearrange it. Let's put our like terms together. 4 times 3 times A cubed squared times A cubed times B to the 4 times C. Do you see anything up there that may have the same base?
No. Well,
Is A also the same as A? Is that the same base?
Well, A and A are the same.
They are, aren't they? Is A the same as A?
Yeah.
So how would I deal with these exponents? They're multiplied together. What power law do I use?
product.
Product law. So 4 times 3 is 12. A times A, or this is going to be A to the 2 plus 3. What do I do with these B's? 1 plus 4 times C. So guys, what you're doing is you have to look at each variable as its own base. If they're multiplied together, you can pull them apart. Do you guys see that?
Yes.
So this one here would be 12, a to the 5, b to the 5, c. And we've just multiplied them together. Now, what would happen here if I divide this by 4a, b, c?
1, 2, 3. A, B, C.
I think I called for that one. Okay, so this is my problem right here. Can you start to see the bases? Yeah?
So the way you would do that is you would, so for each number it would kind of cancel out. So
Yeah.
it would end up as a to the power 4.
Yeah.
And b to the power, and then b cancels, no, b to the power 4.
Yeah.
And then c disappears completely because it's canceled out.
That's right, because look at 12 divided by 4 gives me 3. A5 divided by a. How would I do that in the quotient law? A to the 5 minus 1. Now you can do this kind of intuitively. But if you're looking for the math, that's why these cancel out. This becomes a 4 and this one's gone. Okay? So far so good? Does that clarify that at all or does it make it more complicated?
4 4s.
Both
All of the above. I agree with all of the above.
I agree with all of the above. Okay, so last thing. This here, when I have 2xy cubed plus 3x for y squared plus 4 minus 2x y3, let's make that a 12, plus 4y squared, 8y squared. Who remembers how to deal with this when I'm adding or subtracting monomials and binomials? Yeah,
Isn't there a 1 in front of the bracket so it's not going to distribute out?
that's right. So this would actually be a -1 that we have to distribute in. When we do this, we're adding. Do you remember how the laws don't actually apply to the same as multiply as they do to add and subtract? Is that between them?
Yeah.
That's awesome. So we'll write this one down, 2xy squared plus 3y plus 4y squared. Now I distribute in, so it's going to make each term the opposite. So -1 times 12 gives me -12x y cubed minus, because I have a -1 times positive 8, -8y squared. Now what can I do with this?
So, put
How-
the like terms together.
Yeah, exactly. That's the only other skill you need to know in this whole unit is like terms. I have xy squared. Do I have another xy squared?
Yeah.
No.
Yeah.
I don't.
Yes, you do.
Where?
Oh, no, never mind. Sorry, not square.
I wrote it wrong. That was supposed to be. I got a -12xy cubed. I have a y squared here. And I have a y squared here. So I could put those two together. So I get 2xy squared minus 5y squared plus 4. That's as far as you can go. That's the whole thing. Yeah.
Can I just use the washer?
Uh,
No.
by all means, go ahead. Right. Are there any questions on this part? The adding or subtracting?
No.
You're okay? By the way, what happens if we also have a multiply here by 2x? What would we have to do?
Distribute?
Distribute. 2 and 2, x to x, y and not y. Okay? Does that make sense? Yeah? No questions? All right. Good luck.
Well, good luck.
What?
Wait, what?